Okay, so good afternoon. Good afternoon. So here the participants are coming very slowly. Okay, so in the last class, we have discussed the concepts of unit and dimensions of fluid mechanics. So what are the units we are using in the fluid mechanics? What are dimensions we are using in the fluid mechanics? We have come across the mass, the temperature, time, the length. So like this, we have got some of the units and dimensions. Based on the units and dimensions, we have to start some problems based on that units and dimensions. So here in this class, we'll discuss some of the applications what we have discussed in a briefing, and also some of the properties of fluids which we come across for doing the problems. Okay, next. So if we go to the next slide, we go to the next slide here. So here we see the applications of fluids. Here the applications of fluids at this point of time. So we come across various types of commercial applications, industrial applications, as well as laboratory applications at this point of time. Okay. So here, what are the main applications we are using in the fluid mechanics? Starting from mechanical engineering to the hospital management, we are using various types of applications which are related to the fluid mechanics concept. Fluid mechanics concept. So what is the applications we are using? See here, here we are applying, here we are applying the fluid mechanics concept for the manufacturing of artificial heart, for the manufacturing of artificial heart. So see the figure here, here this is a pumping system where we are using the pipes, the flow of blood from the different electrical instruments. Here the blood is flowing to the arteries of the artificial heart. So here also how much amount of blood is going in, how much amount of blood is going out, we can see at this concept. If you see the natural flows and weather reports, so see the natural areas where you come across the big waterfalls or big dams, big storms of water coming from the natural things. See how the water is flowing from the top surface and falling into the valley, thereby how the fluid mechanics going dynamically. Now, in the water power plants, in the power plants also we are using the gas as a medium and also water as a medium. So these are the cooling towers. So these are the cooling towers where we have to cool these towers, with high capacity of water, water, high capacity of water. So here also in the power plants, we are using the concept of fluid mechanics. Now see the for shipbuilding and aircraft applications. See here for the boats. So the ships, boats, steamers, all are floating on the riverbed or on the seabed, on the waterbed. So how they are moving, how they are flowing, how they are doing, it all depends upon the dynamics of fluid mechanics. Next, see the aircraft and spacecraft. So here also we are using the fluid mechanics in the form of gas, air, how they are moving, how the planes are moving in the air, human body. So in the human body also we are using the concept of fluid mechanics. So for the diagnostics or some sort of dialysis, or the human body itself acting as a fluid mechanics, how the blood is flowing, how the oxygen is flowing, how the water is flowing inside the body. We can see all these types of concepts in the human body. Next, cars and automobiles. So in the cars and automobiles, obviously we are having the engine oil, obviously we are having the petrol and diesel. Here also we can see how the fluid or gases are moving and taking different parts and giving the output to the automobiles. So like this we are having other applications like wind turbines. So what is the major purpose of wind turbines here? The main intention of wind turbines is to generate electricity by taking the input medium, that is wind. Here also how the gases are reacting in a form of how the wind turbines are moving, how we are getting electricity, how the wind is taking place, the rotation of the wind turbines and converting into electric energy. we can see this all type of fluid is in this wind turbines. Next, pumping and plumbing systems. Pumping, piping and plumbing systems. So what happened here in the piping and plumbing systems? Generally for civil engineers, you have to know what is a piping system, what is a plumbing system. You will come across these subjects in the later uh, years. So see the pipes here, see the water pipes. Some water pipes may be hot water pipes, or some may be cold water pipes. See the joints, how the joint is arranged, how the joint is placed, one pipe, two pipe, and third pipe. Here you are having a three joint, here you are having a two joint. So like this you are having the joints. So with the valve, the pressure regulator valve. So here also how the water is flowing from here to here, how it is taking a conversion like this, and how it is flowing in this direction. At this point, the fluid is taking some pressure because the pipe is bent at this point, joint is bent at this point. So like this, we are having different fluid mechanics concept in the piping and plumbing, and also industrial applications where the fluid is flowing in different chambers and taking place the reaction, how the reaction takes place in the industrial applications. So like this we can see here also in the industrial applications. Now we'll see what are the basic properties of fluids, how the properties of the fluids react according with the applications or according with the atmospheric conditions, right? Now any characteristic of a system is called property. So general గా ప్రాపర్టీ అని ఎలా చెప్తున్నాము, ఒక ఆబ్జెక్ట్ కి ఒక సిస్టమ్ కి ఒక క్యారెక్టర్ అనేది ఉందంటే we are calling them as property. What is your property? Your attitude is your property, your character is your property. So like that, any object, any system in the universe has some sort of properties. What are those types of properties? Please we'll discuss slowly one by one. Okay, next. So what does the general familiar things what already you know you discussed in the other previous classes are pressure P. What is the pressure? Force applied is the pressure. Temperature T. Volume V. Mass M. Other familiar things like viscosity, thermal conductivity, modulus of elasticity, thermal expansion coefficient, vapor pressure, surface tension. మనకి జనరల్గా మనకు తెలిసినగా ఫెమిలియర్గా మీకు తెలిసినవి ఏంటి, టెంపరేచరు, వాల్యూము, ప్రెషరు, మాస్. So apart from that, other familiar or properties of fluid are viscosity, viscous in nature, thermal conductivity, so capacity of conducting thermal things, modulus of elasticity, thermal expansion coefficient, vapor pressure and surface tension. Vapor pressure and surface tension. These are some of the other properties of any fluid. It may be a water, it may be a kerosene, it may be a petrol, it may be a other materials. Next, intensive properties. So intensive properties are dependent or independent of mass of the system. So whenever you are having a system, respective to the boundary, so the intensive properties are independent of the mass of the system. So what are these intensive properties? Temperature, pressure and density. Temperature, pressure and density are the intensive properties which are independent to the mass. Okay, then what are the extensive properties? The extensive properties are those whose value depends on the size. ఇక్కడ మాస్ మీద డిపెండ్ అయ్యింది ఇంటెన్సివ్ ప్రాపర్టీస్. ఎక్స్టెన్సివ్ ప్రాపర్టీస్ ఆర్ డిపెండెడ్ ఆన్ size of the system. So what happens here? The examples are total mass, total volume and the total momentum. The examples are total mass, total volume and total momentum, right? Next, extensive properties per unit. The extensive properties per unit. The extensive properties per unit. See, the extensive properties per unit can are called the specific properties. The extensive properties of the unit are called specific properties. The extensive properties of the unit are called the specific properties. So these are the what are the examples here? The examples are the specific volume where capital small v is equals to volume by mass, and specific total energy energy E is equals to capital E by mass. Total energy by the mass. So like this we are having some familiar characteristics and less familiar characteristics like pressure, temperature, volume and mass, whereas other things are first one modulus of elasticity, thermal conductivity, thermal expansion coefficient and vapor pressure and surface tension. సో ఇక్కడ ప్రాపర్టీస్ లో రెండు రకాలు ఉంటాయి, ఇంటెన్సివ్ ప్రాపర్టీస్ అండ్ ఎక్స్టెన్సివ్ ప్రాపర్టీస్. ఇంటెన్సివ్ ప్రాపర్టీస్ ఆర్ దోస్ which are independent to the mass of the system. Example, what are the examples here? The temperature, the pressure and the density. So these are the examples of intensive properties of the system. Then what are the extensive properties? The extensive properties are those depends on the size of the system. ఇక్కడ దేని మీద డిపెండ్ అయింది? Depends on the mass of the system, whereas it depends on the size of the system. It depends upon the size of the system. What are the examples here? The total mass, the total volume and the total momentum. So ఈ words already మీరు physics concept లో ఎక్కడో చోట you have already familiar with these things. So మనకి problems point of view లో మనం తెలుసుకుందాం. And also what are the physical properties of the fluids గురించి తెలుసుకోవడానికి we are just recollecting this topics. Now see in depth. The first thing is what is the density or mass density. So what is a simple thing? Density is equals to mass of fluid. Density is equal to mass of fluid by volume of fluid. Density means సాంద్రత. In Telugu we are calling them as సాంద్రత. Density ante సాంద్రత means. Okay. So here what is density? Mass by volume. Simple ga cheppali. How it is defined? It is the ratio of mass of fluid to the volume of fluid. Density is measure of the amount of fluid contains in the given volume, which contains in the given volume. Density of a fluid is defined as the ratio of the mass of the fluid to the volume, or simply mass per unit volume. We are calling simply as mass per unit volume. That is mass per unit volume. P is equals to m by v. Rho is equal to m by v. It is called as density. It is denoted by rho or h antam. Just like P lagane untundi. It is defined like rho, like this. Rho is equals to mass by volume. Now the SI units of the density are kg per meter cube. kg per meter cube, the SI units. Whereas the density of liquids may be considered at the constant, while the gas changes with the variation. The density of water is 1000 kg per meter cube or 1 gram per centimeter cube. Okay, the SI units for the density is denoted by kg per meter cube. ఎందుకంటే మాస్ బై వాల్యూమ్. మాస్ ఎట్లా దేంతో డినోట్ చేస్తాము? kgs లో. వాల్యూమ్ దేంతో డినోట్ చేస్తాము? మీటర్ క్యూబ్. Right? So like this, mass per meter cube. So if you have any audio and video problem, just chat me in the text box. Okay, next. Specific weight or weight density. So the second thing is specific weight or weight density. So what is the meaning here? It is the ratio of weight of fluid to the volume of fluid. Akkada mass, ikkada weight. So directly we are discussing with the mass and weight. So here the specific weight is defined as specific weight మాత్రమే calculate చేస్తున్నప్పుడు we are calling them as a specific weight or specific weight density. It is defined as the ratio of weight of the fluid to its volume. దాని volume తో దాని weight ఎంతనో మనం చెక్ చేస్తున్నాం. That is nothing but the specific weight of the fluid, or simply the weight per unit volume. The simply weight per unit volume of fluid is called weight density. We are calling them as weight density. It is denoted by weight density is denoted by W, and SI units we can say it is Newton per meter cube or kilonewton per meter cube. Newtons per meter cube or kilonewtons per meter cube. Then what is the specific weight? Small w is equals to weight of the fluid by volume of the fluid. So the density ante mass of fluid by volume of fluid. Here specific weight or weight density is equals to weight of the fluid by volume of the fluid. So ఈ రెండిట్లో కింద denominations V ఉంది కాబట్టి simply you can remember mass density or density is equals to mass of fluid by volume of fluid. Weight density is equals to weight of fluid by volume of fluid. That is equal to small v is equals to capital W by capital W by capital V. Next, that small w is equals to weight density is equals to weight of the fluid ఎలా చేస్తున్నాము m into g where capital W is equals to mass into gravity. So mass into gravity. ఇప్పుడు దీన్ని మనము ఇంకా సింప్లిఫై చేసినప్పుడు w is equals to m by v ఏంటి the previous definition we are having m by v is equals to rho. Now దీనికి అప్లై చేస్తున్నప్పుడు ఏం జరుగుతుంది w is equals to rho into g, that is equals to w is equals to rho into g. We got this formula for weight density. Now the value of specific weight of water, generally 9 is equals to 9.81 kilonewton per meter cube in SI units. So that is the specific weight of water. For any problems, if G is not given, just assume it 9.81 kilonewton per meter cube. Okay. So that is the second definition which we have discussed in the properties. First one is a mass density. Second one is a weight density. Next, third one. Specific volume. Specific గా మనం volume ని choose చేసుకున్నప్పుడు we are calling them as specific volume. Then what is the specific volume here? It is the volume of fluid defined as a volume occupied by the unit mass. It is a fluid that it is defined as the volume occupied by the unit mass or volume per unit mass of the fluid. So specific volume small v is equal to volume of the fluid by mass of the fluid. ఇక్కడ ఏం జరిగింది వాల్యూమ్ ఆఫ్ ద ఫ్లూయిడ్, ఇక్కడ మాస్ ఆఫ్ ద ఫ్లూయిడ్ బై వాల్యూమ్ ఆఫ్ ద ఫ్లూయిడ్. ఇక్కడ ఏం జరిగింది రివర్స్, వాల్యూమ్ ఆఫ్ ద ఫ్లూయిడ్ బై మాస్ ఆఫ్ ద ఫ్లూయిడ్. జస్ట్ రివర్స్ అయింది. ముందు దానిలో ఏమైంది m by v ఉంది, ఇక్కడ v by m అనేది తీసుకున్నాం. సో స్మాల్ v is equals to volume of the fluid by mass of the fluid. How we can denote this one? Small v is equals to capital V by small m. That is equals to 1 by rho. అంతే కదా, దాన్ని రివర్స్ చేయాలనుకున్నప్పుడు 1 by rho అని చెప్తాము. That is a specific volume. Next. Specific gravity. The fourth definition is the specific gravity. What is the meaning of specific gravity here? What is the meaning of specific gravity? Here, the specific gravity is defined as the ratio of specific weight. It is defined as the ratio of specific weight or density. Specific gravity is defined as the ratio of specific weight of the fluid to the specific weight of the standard fluid. Fluid standards and fluids we are having some standard notations and also some standard formulas. So based upon the standard fluid notation, general fluid ki manamu anusandhanam chestamu. Then what is the specific gravity? Specific gravity is defined as the ratio of specific weight of the fluid to the specific weight of the standard fluid. So for liquids ki the standard fluid is taken as water, and for gases ki the standard fluid is taken as air. So generally ga standards అనేది కొన్ని కొలతలు, కొన్ని మెజర్మెంట్స్, కొన్ని స్టాండర్డ్స్ దాని బేస్. ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ వాంట్ టు మెజర్ సమ్ a pencil or any small eraser, దేంతో మెజర్ చేస్తారు? స్కేల్. సో if you take a scale of 30 centimeters or 15 centimeters, both are applicable for measuring the pencil. But what is the standard you are taking? Eraser ని మెజర్ చేయాలన్నప్పుడు స్కేల్ కావాలి, పెన్సిల్ మెజర్ చేయాలన్నప్పుడు స్కేల్ కావాలి. బట్ పెన్సిల్ మెజర్ చేయాలన్నప్పుడు స్కేల్ కాకుండా ఇంకేమన్నా యూజ్ చేయొచ్చా? మీన్స్, సో ఇఫ్ యు నో ద స్టాండర్డ్ లెంత్, ఫర్ ఎగ్జాంపుల్ వాట్ ఆర్ ద మ్యానుఫ్యాక్చరర్స్ ఆఫ్ పెన్సిల్? నటరాజ్ పెన్సిల్స్, క్యామ్లిన్ పెన్సిల్స్, ఇంకా So like this, if you see the manufacturers, andaru, the length and the diameter of the pencils will be same. So if you take a standard of a pencil dimension is so and so, then scale lekunda we can check the other pencil length. So the standard dimension should be there for anything to measure. Now specific gravity is also called as relative density. Specific gravity ni manam other name em pilustunnamante relative density we are calling it. It is the dimensionless quantity and is denoted by symbol S. Now the specific gravity is denoted by the symbol S for liquids. Now what is the formula? Specific gravity S is equals to specific weight of the specific weight of liquid by specific weight of the water. అంటే వాటర్ మనం తీసుకుంటున్నాం కదా స్టాండర్డ్ వాటర్ తీసుకుంటాం కాబట్టి వీఆర్ అప్లైయింగ్ వాటర్. నౌ specific weight of the liquid divided by specific weight of the water, that is equals to W weight of liquid by W weight of water. What is the weight మనం ఏమనుకుంటున్నాము? That is a rho liquid by rho water. Now S for gases, specific weight of gas divided by specific weight of air. From this above equations మనం ఏం చెప్తున్నాం? S density, specific gravity S is equals to density of water. From above equations liquid గురించి ఏం చెప్తున్నామంటే specific gravity is equals to density of water, that is equals to S into density of water ఎలా చెప్తున్నాం? 1000 kg per meter cube. 1000 kg per meter cube ముందు మనం చెప్పుకున్నాం. The water, you are having 1000 kg per meter cube. That is the standard for the density of water. Now S is equals to 1000 kg per centimeter, 1000 kg per meter cube. Now if you take some of the formulas based on the 4 or 5 formulas what we have discussed, we are having some problems, very simple and easy problems which you can understand very easily. Now see here, the first problem, calculate the specific weight, calculate the density, calculate the specific volume and specific gravity of a liquid, having the volume 6 meter cube. ఇక్కడ మీటర్ క్యూబ్ అనేది ఎందుకు వచ్చింది? బికాస్ యు ఆర్ హ్యావింగ్ 3 measurements, length, width and height, and weight is 44 kilonewtons. So if this is a problem given, then what is the first, for any problem just you have to write down the given data అనేది ఫస్ట్ రాసుకోవాలి ఏ ప్రాబ్లమ్స్ కైనా ఏ సబ్జెక్ట్ లో అయినా. సో ఇఫ్ యు ఆర్ నాట్ మెయింటైనింగ్ ద గివెన్ డేటా 2 మార్క్స్ అనేది ఈజీగా యూ కెన్ లూజ్. Why? Because in the exam point of view లో మీకు ప్రాబ్లమ్ చదివిన తర్వాత సొల్యూషన్ రాకపోయినా ఫార్ములా రాకపోయినా జస్ట్ రైట్ ద గివెన్ డేటా వాట్ ఈస్ దేర్ ఇన్ ద క్వశ్చన్. బట్ యాజ్ ఇట్ ఈస్ రాయొద్దు, గివెన్ డేటా అని రాసి దెన్ సి వాట్ ఆర్ ద వాల్యూస్ గివెన్ ఇన్ ద క్వశ్చన్. ఫస్ట్ రైట్ ద వాల్యూస్ గివెన్ ఇన్ ద క్వశ్చన్, లేటర్ వాట్ టు ఫైండ్ అవుట్, ఏం కనుక్కోవాలి, టు ఫైండ్ అని పెట్టి రైట్ ద find and better question mark. So if you know the formula, write the formula and keep in the box. If you don't know the formula, అంతవరకే రాసి వదిలేయండి, but don't do nonsense things. అప్పుడు ఏం జరుగుతుంది? సో ఎవాల్యుయేషన్ చేసినప్పుడు గివెన్ డేటాకి విల్ గెట్ 1 or 2 marks, depends upon the weightage of the marks. 8 marks అనుకోండి, definitely will get 2 marks. If it is 2 marks problem or 4 marks problem, you will get 1 mark. Why to lose the 1 mark? So write the given data as per the norms. Okay, next, what is the given here? The volume is given. What is the volume? 6 meter cube. What is the volume? 6 meter cube. Now what is the weight? 44 kilonewtons. Convert it into newtons ఎందుకంటే మీటర్ లో ఉంది కాబట్టి there is no problem. So 44 into kg ని 10 to the power of 3 అని రాస్తున్నాము. Kilo Newton is equal to 10 to the power of 3 Newton. Then what is the specific weight? The specific weight W is equals to weight of the liquid by volume of the liquid. As I already mentioned in the earlier formula, specific weight is equals to weight of the liquid by volume of the liquid. Next, then what is the weight of the liquid? 44 kilonewtons, that is equals to 44 into 10 to the power of 44 into 10 to the power of 3. 44 into 10 to the power of 3 by Volume of the liquid anta 6 meter cube ichadu. So 6. Then after deriving this one, you will get 7.33.3. Right? This is the answer for the specific weight. Now what is the second one? Density kanukkoli. Density formula manaku telusu. Rho is equals to W by G. ఆల్రెడీ మనం స్పెసిఫిక్ వెయిట్ కనుక్కున్నాం కాబట్టి W కీప్ ద వాల్యూ W ప్లేస్లో పెట్టండి. తర్వాత G మనకి ఆల్రెడీ తెలుసు, దట్ ఈస్ 9.81 kg per centimeter, kg per meter. నౌ 9.81 G ఆల్రెడీ మనకి తెలుసు. సో ఇక్కడ క్వశ్చన్లో G వాల్యూ ఇవ్వలేదు. Therefore we have to take the G value is equal to 9.81 meters. Now convert this, you will get 747.5 kg per meter cube. That is the answer for the density. Next, specific volume. What is the specific volume? V is equals to 1 by rho. Already మనం చెప్పుకున్నాం 1 by rho అని. Where is 1 by rho? See here, the V is equals to 1 by rho. Now apply this formula. At this point. Apply this formula at this point. Now small v is equals to 1 by rho. మనకి డెన్సిటీ రో ఆల్రెడీ వచ్చింది కాబట్టి దీన్ని ఇక్కడ సబ్స్టిట్యూట్ చేయండి. అండ్ ఆటోమేటికల్లీ ద ఆన్సర్ ఈస్ 1.34 into 10 to the power of 3 meter cube per kg. Next, last one is specific gravity. Specific gravity S is equals to weight of the liquid by weight of the water. Specific gravity ఎక్కడ ఉంది? ఇక్కడ weight of the liquid by weight of the water. Apply this formula at this point. Now what is the weight of the liquid? The weight of the liquid is 7,333. Then what is the weight of the water? 9810. ఇక్కడ ఉంది కదా, into 1000 సబ్స్టిట్యూట్ చేస్తే మీకు 9810 ఈ వాల్యూ మీకు తెలియదు. But we have to take these values and these values based upon the question what it is given. So weight of the water is 9810. Weight of the water is 9810. Therefore, what is the total answer here? The specific gravity is 0.747. Specific gravity is 0.747. Next one. Under late admit avutunnaru. Now see the second question. Determine the mass, density, specific volume and specific weight of a liquid whose gravity is 0.85. So ఇక్కడ ఓన్లీ ఒకటే వాల్యూ ఇచ్చాడు. ఏంటది? స్పెసిఫిక్ గ్రావిటీ ఈజ్ ఈక్వల్స్ టు 0.85. స్పెసిఫిక్ గ్రావిటీ సింబల్ ఏంటి? ఎస్. సో మన గివెన్ డేటాలో యూఆర్ హ్యావింగ్ ఓన్లీ వన్ డేటా. సో వీ నో వాట్ ఈస్ జీ. ఓకే, వీ నో వాట్ ఈస్ జీ. నౌ వాట్ ఇస్ ద థింగ్స్ టు ఆస్క్? ద మాస్ డెన్సిటీ కనుక్కోవాలి, స్పెసిఫిక్ వాల్యూమ్ కనుక్కోవాలి, స్పెసిఫిక్ వెయిట్ కనుక్కోవాలి. నౌ మాస్ డెన్సిటీ ఫార్ములా వేయండి. వాట్ ఇస్ ద మాస్ డెన్సిటీ? S is equals to mass into mass of the density of liquid is equals to S into mass density of water. S into mass density of water. That is rho is equals to 0.85. Mass density and unit rho. S value ఇక్కడ సబ్స్టిట్యూట్ చేయండి 0.85. తర్వాత into mass density of water అంటే 1000. ఈ 1000 ఎలా వచ్చింది? You have to assume. See here, you have to the mass density of water is equals to 1000 kg per meter cube. 1000 kg per meter cube. ఇక్కడ మీరు ఆల్రెడీ వేశారు 1000 kg per meter cube. Substitute these values in the formula. Based upon the formula ఇచ్చిన క్వశ్చన్ బట్టి మీరు వాల్యూస్ తీసుకోవాలి. Okay, now here rho is equals to 0.85 into 1000. That implies 850 kg per meter cube. So you got the mass density. And what is the specific volume? V is equals to 1 by rho. ఈ ఫార్ములాస్ మీరు ఆటోమేటిక్గా గుర్తుపెట్టుకోవాల్సిందే. ఎవ్రీ టైమ్ యూ కెనాట్ రిపీట్. ఓకే, నౌ స్మాల్ v is equals to 1 by rho. Rho వాల్యూ మనకు తెలిసింది కదా. అప్లై హియర్, యూ విల్ గెట్ 1.176 into 10 to the power of 3 meter cube. Third one, specific weight. What is the specific weight formula? Specific weight formula is equals to W is equals to rho into rho into G. Specific weight is equal to rho into G. వచ్చిన వాల్యూస్ ఏమొచ్చింది ఇక్కడ? What is the rho value? Rho value is 850 and G value is 9.81. Finally, the answer is this one. అర్థమైందా? Next. Audible? What is the viscosity? Viscosity is defined as the property. Viscosity is defined as a property of fluid by the virtue of which it offers resistance. Resistance to the movement of one layer of fluid over the another adjacent layer of the fluid. It makes the virtue of it offers the resistance it offers the resistance కాన్సెప్ట్ ఒక లేయర్ కి రెసిస్టెన్స్ ని మెయింటైన్ చేస్తున్న ప్రాపర్టీని ఏమంటామంటే విస్కోసిటీ అని అంటాము. అగైన్ హియర్ ఒక లేయర్ నుంచి అదర్ లేయర్ కి విస్కోసిటీ రెసిస్టెన్స్ అనే కాన్సెప్ట్ పెట్టుకొని జరిగేదాన్ని విస్కోసిటీ వీఆర్ కాలింగ్ దెమ్. నెక్స్ట్, viscosity of a fluid determines its resistance to shearing stresses. సో జనరల్లీ ఒక లేయర్ మీద ఒక లేయర్ ఉన్నప్పుడు ఆటోమేటిక్గా షియర్ స్ట్రెస్ అనేది ఫామ్ అవుతుంది. సో ఇన్ ఆర్డర్ టు resistance, viscosity is the good property. Then viscosity is primarily due to the cohesion and molecular momentum exchange between the fluid layers. ఒక లేయర్ కి ఒక ఫ్లూయిడ్ లేయర్ కి అదర్ ఫ్లూయిడ్ లేయర్ కి whenever the cohesion takes place, whenever the rubbing action takes place, and the molecular momentum of the molecules takes place, at that point we are calling them as viscous nature of the fluid. Now see, this is one plate, this is one fluid place, this is other fluid plate. This one is stationary, this one is a stationary moving plate, this one is a moving moving plate. Then when this are touching this one, see, just for a diagrammatic representation, when this is moving in this direction, making a stress, see a stress. So you are having a distance of y, you are having a distance of y. Here the velocity profile is slowly increasing in this way with the difference of dy. Here the change displacement is, total displacement is u. Here in this, whenever you are changing the displacement, u plus du, with the changing is du, changing in the du. So the fluid motion between the two parallel lines is discussed by this figure. So ఇట్లనే figure వేయాల్సిన అవసరం లేదు. We can take any layer and show how the displacement and how the velocity actions take place. So consider two plates. Is it visible? Audible? Okay. It is moving concept. Now the lower plate is assumed to be at rest. కింద ప్లేట్ మనకి రెస్ట్ పొజిషన్ లో ఉంది, జరగట్లేదు. పైన ప్లేట్ వచ్చేసి మూవ్ అవుతుంది. విత్ ద అప్పర్ వన్ ఈస్ మూవబుల్. నా మ్యాథమెటికల్ ఎలా రాస్తాము? ఇక్కడ షియర్ స్ట్రెస్ ఈజ్ ఈక్వల్స్ టు ద షియర్ స్ట్రెస్ ఈజ్ ఈక్వల్స్ టు du by dy, tau is equals to du by dy, or the mu is a coefficient where mu is equals to du by dy. Now where mu is a constant proportionality and is known as coefficient of dynamic viscosity, లేదంటే ఓన్లీ విస్కాసిటీ అని చెప్పచ్చు. Now du by dy is equals to rate of shear strain or rate of shear deformation or velocity gradient. du by dy is equals to velocity gradient అని చెప్తున్నాం. Rate of shear strain, rate of shear strain, rate of shear strain du, or rate of shear deformation or velocity gradient. Now from the above equation we can say, from the above equation 1 we can say mu ని తీసుకొచ్చినప్పుడు tau అటు వెళ్ళినప్పుడు tau by du by dy. Now this can be defined as shear stress by shear strain, shear stress by shear strain. Mu is equals to shear stress by shear strain. Okay, coefficient of dynamic viscosity is equals to shear stress by shear strain. Then units of viscosity యొక్క units ఏంటి? The units of viscosity are obtained by putting their dimensions in the quantities. So whatever the quantities మనం ముందు చెప్పుకున్న దాంట్లో డైమెన్షన్స్ యూనిట్స్ కి ఇక్కడ అప్లై చేసినప్పుడు mu is equals to shear stress by du by dy అంటే ఏంటి? Change in the velocity by change in the distance. U is equals to velocity, y is equals to distance. Now change in the velocity by change in the distance, that is equals to, now units దానికి అప్లై చేయండి ఫార్ములా. Shear stress is equals to force by area, shear stress is equals to force by area. Next, change in velocity అంటే ఏంటి? Force change in velocity is equals to length by time by change in the distance. Change in the distance అంటే length, that is 1 by length. దీనికి డినామినేషన్ న్యూమరేటర్ పైకి తీసుకున్నప్పుడు change in the velocity is equals to length by time into 1 by length. Then దీన్ని సబ్స్టిట్యూట్ చేస్తే ఏమొస్తుంది? Force, that is mu is equals to force into length పైకి వెళ్ళినప్పుడు ఏమో జరుగుతుంది? స్క్వేర్ అవుతుంది. సో హియర్ it is making square. You are having two lengths, it is making square. Now length square by 1 by time, that is equals to force into time by length square, that is equals to force into time by length square. Now in SI systems the force is represented by newtons. In SI systems lo newton ga represent chestunnamo. The length is represented by meters. In MKS system the force is represented by kg force and the length is represented by say meters. So SI systems, MKS systems, SI systems we are having ఇవన్నీ మీకు ఆల్రెడీ తెలుసుంటాయి. MKS systems ఉన్నాయి and CGS system. So here in the SI system the Newton N, in MKS system the force is represented as kgf, whereas in the CGS system the force is represented by dyne. So ఈ వర్డ్స్ మీరు గుర్తుపెట్టుకోవాలి, dyne, and the length in the centimeter. సో ప్రాబ్లమ్స్ లో CGS systems లో చేయమన్నప్పుడు ఇలా చేయాలి, MKS systems లో చేయమన్నప్పుడు ఇలా చేయాలి. జనరల్ గా ఏమి ఇవ్వనప్పుడు SI systems లో చేయడం is better. Now the SI systems of viscosity is equals to Newton second by meter square, that is equals to PAS. Whereas in MKS units మనం ఇక్కడ రాసుకున్నాం kgf per second by meter square. In CGS 9 second per meter square, that is equal to poise. So 1 Newton second by meter square is equal to 10 poise. 1 poise is equals to 1 by 10 Newton second by meter square, and 1 kgf per centimeter meter square is equals to 98.1 dyne per centimeter square, that is equals to 98.1 poise. Poise is equals to 1 poise is equals to 1 by 10. అందుకే ఇక్కడ 98.1 నుంచి 9.81 దగ్గరికి వచ్చింది, right? Sometimes the unit of viscosity of the center poise is used where 1 centipoise is equals to 1 by 100 poise. So 1 poise is equals to 1 by 10, 1 centipoise is equals to 0.01. Now the viscosity of water at 20 degrees centigrade is equals to 0.01 poise or 1 centipoise. So you have to remember these things only during the problems point of view. Okay, so academic viscosity, తర్వాత దాని problems, and what is the viscosity, surface tension, bulk modulus. We'll discuss these topics in the next class. Okay. If you have any doubts, just raise your hands. So here today the attendance is 7 members. Today the attendance are 7 members. I am taking the screenshot, but అందరూ available గా ఉండండి. So if you have any problems, message me personally. Okay. So the screenshot I am taking now. Okay. So if you have any doubts, just message me, or you can unlock and talk to me. So